Welcome to my channel. On this video, I'm going to teach you how to use the integral test to determine whether a function converges or diverges. Please don't forget to subscribe to my YouTube channel. Thank you very much. Let's start. So using the improper integral test to determine whether a function diverges or converges. One note, one may ask, what is improper integral? When we talk about improper integral, what is it about? Let's look at something about it. So when we talk about improper integral test, the improper integral test is in two parts. We have the finite limit of integration and the discontinuous integrand. Okay, let's talk about this. With the infinite limit of integration, this is an example of the infinite limit of integration, whereby we are integrating 1 over x squared dx with a limit of 1 to infinity. So it means that the intervals is very huge, therefore it is up to infinity. That's why we call it infinite limit of integration. And with the discontinuous integrand, now you integrating 1 over x squared dx with an interval of -1 to 1. Now we are going to look at a value that when you put it inside x will make this x undefined, and the interval is from -1 to 1. So starting from -1, 0, 1. Now when you put 0 here, it's going to make this whole function math L, because you're going to get 1 over 0, which is you cannot work with that. That's why we call it discontinuous. So there's discontinuity in the intervals. So let's talk about how the infinite limit of integration can be broken down using the infinite limit of integration to find whether a function diverges or converges. So with the infinite integration, you're going to represent the infinity sign with an alphabet. So you can choose any alphabet of your choice, making A, B, and you take the limit of the function. So the limit of the function as the A approaches infinity, and you're going to replace this with what? The A. It has been replaced with the A. As you can see, it has been replaced with the A. So it has been replaced with the A. Well, now you're going to do your normal integration with the function given to you, and after you're going to put the values inside. Now after doing that, when you put the values inside, that's you're going to use A, but now A is approaching to infinity. So wherever you see A in the function, you're going to put infinity inside after you get your answer. Now let's look at how the discontinuing integrand is. With the discontinuous integrand, what you need to know is you're going to break down into two. So you're going to integrate from 1 to the number which makes the function discontinuous, or to the number which makes the function undefined. So we know that the number is from -1, 0 to 1. So you're going to, from -1 to 0, 0 is making the function undefined, right? So what you need to do is now you're going to make the 0, you're going to break down into 0. So you're going to integrate from 1 to A. So you're going to represent, now we know mostly with the discontinuous integrand, we need to know the number which is making, or the interval which is making the function undefined. Now here, we know that from here, let's use this function as an example. We know that the number is what? 0. So we are going to replace that 0 with what? A number, with an alphabet. So now we know that this is 0. So when putting this limit, you write limit as A approaches to what? 0. Because what you need to know with the discontinuous integrand is that you need to find that number that is making the function undefined. So you're going to integrate from 1 to 0, and from -1 to 0, and from 0 to +1. So this is what you're going to do. So this 0 here is because here we are going to start from -1 to the interval that makes the function what? Undefined. So here will be what? 0. So that will be the first one. And we're going to integrate from 0, that is from 0 to 1. So the A that, or the alphabet you choose should represent the number which is making your function undefined. Thank you. Now, with the convergence and the divergence test, we are using type 1. Wow. When the improper integral, that is f of x dx, and that is the improper of integral of f dx and this, are called convergent if the corresponding limit it exists. So when you solve, after doing your own all this and you solve, you put the values inside and you get the limit to exist. Therefore, the function is convergent. And when you solve and the limit does not exist, the function is divergent. Let's move on. So let's take example. Determine if the following integral is convergent or divergent. With this, now we know this is our function. This is our function. So what we need to know is find the interval which will make this function undefined. Now when you put 3 here, it's going to be 0. Root of 0 is 0. 1 over 0 is undefined. So it means that we've getting the function, or we've getting the interval, which is what? 3. So we are going to replace here with an alphabet. So here they replace there with an alphabet of t. Therefore, t is approaching the limit of the integral of 0 to t. That's the interval 1 over root of 3 minus x dx. So now we are replacing the 3 with what? T. As what? T approaches to 3. I get in it. Now, after doing your normal integration with this, you're going to get negative 2 root 3 minus x, the interval of 0 to t. So as t approaches to what? 3. So after putting your values inside, wherever you see t, this is t, you put your what? Your 3 inside. So here to make it 0. So you're going to get 0 here, and here, since it's 0, you're going to get positive 2 root 2. So since we're getting a limit that exists, the limit exists and is also finite, the integral converges. So this is simple. Let me teach you another thing. When we call something p series, that is 1 over n exponent p. So with this p series, it's simple. You can apply here. When a question is given to you and the exponent of this is the exponent of this, for example, maybe 1 over, let's take about, let me, x squared. So they gave us this interval, and this is maybe infinity and 1. This is infinite infinity because it has a lot of, the interval is very huge. So with this, with what we call it the p series, when the exponent here is greater than 1, it converges. So when p is greater than 1, it converges. And when p is less than or equal to 1, it diverges. So when a question is given to you and with exponent, you just check the exponent. If it's greater than 1, it converges. And if it's less than 1, it diverges. Thank you very much for watching this video. And please comment to give me more ideas to see how the video is going. And also subscribe to my YouTube videos. Thank you very much. And more videos will be coming.